Welcome to Robinson Foundry. My name's Seth Robinson, and in this video, I'm going to show you how I turned a 3D print into a 5-pound brass statue by using the Lost PLA method. This model is called Avatar of a Dead Emperor, and it was made by an artist named Zane Rogers. I started this project by printing a hollowed-out version of the model on my 3D printer, which took almost 30 hours. I also printed a sprue and some vents, which will be attached to the model later on. These pieces are needed to get the metal into the mold and allow air to escape as it's being filled. Then I went to work removing plastic from the bottom of the model to reveal the hollow. Next, I melted some wax and poured it into the hollow to evenly coat it. This will ensure that the inside of the model is watertight. Then I glued on the sprue, vents, and a handle. The next step was to dip the model into a ceramic material called suspenda slurry. After letting the first coat dry, I dipped the model into the slurry again, but this time I sprinkled it with silica sand, which will help build up a thick shell. The goal here was to build up a thick ceramic shell, which could withstand the temperature of the molten metal. The model was dipped into the slurry and then coated with sand a total of 5 times, followed up by one final coat without sand. Next, I removed the wooden handle and as much plastic as I could. This will help prevent pressure from building up and cracking the shell during the next step. After the shell was completely dry, I placed it into my kiln to burn out the wax and plastic, as well as vitrify the shell, which turns it into a ceramic that can withstand the heat of the molten metal. I baked the shell for a few hours at about 1700 degrees Fahrenheit, or 900 degrees Celsius. The next day, I opened the kiln to discover that despite my efforts, the shell had cracked quite badly. I also noticed a large amount of ash left behind from the plastic. To try and fix the cracks, I simply painted on some more ceramic material and baked the shell again. Now that the shell was done, it was time to melt some metal. For this casting, I needed to make some bronze consisting of 90% copper and 10% tin. First, I melted 9 pounds of copper, which took about 30 minutes in my homemade furnace. Once the copper was melted, I added the tin, which instantly melted in the molten copper. This is because tin has a melting point of 450 degrees Fahrenheit, or 230 degrees Celsius, while copper has a melting point of 1984 degrees Fahrenheit, or 1085 degrees Celsius. I removed the shell from the kiln while it was still hot and placed it in a bucket filled with vermiculite to keep it insulated and prevent it from moving while it's being filled. I let the bronze heat up to about 2100 degrees Fahrenheit, 1150 degrees Celsius, and then poured the metal into the mold. Everything was going well until, just like that, the mold split open at the bottom, spilling out all of the bronze and taking with it all of the time and effort I had put in. It's extremely frustrating when something like this happens, but you just have to stay positive and keep trying. After thinking about my next approach, I decided to toss the idea of trying to make the casting hollow, but this meant making the casting slightly smaller and attaching a very large sprue. A large sprue is necessary because it helps supply the casting with metal as it solidifies and shrinks. I also used a different PLA filament, which I know from experience burns out without leaving any ash behind. And I also made the ceramic shell much thicker this time around. After burning out the PLA, I was disappointed to discover that some areas inside the shell had broken away. At this point, I really wasn't confident that the casting would turn out very well, so I decided to fill the mold with brass instead of my more expensive bronze. Brass is similar to bronze, but instead of being made up of copper and tin, brass is made up of copper and zinc, and as a result has a slightly lower melting point of about 1700 degrees Fahrenheit or 900 degrees Celsius. Once the brass was melted, I poured it into the mold. I was very relieved to see that this mold held up well. I brought the mold into the garage while it was still hot and turned off the lights so that I could see the orange glow of the metal through the shell. After the casting cooled down, I started breaking off the shell, which is always exciting. I noticed some minor issues, but nothing terrible. All in all, it turned out pretty well. To remove the rest of the shell, I blasted most of it off with my pressure sprayer and then finished it up with my sandblaster. Next I went to work cutting off the sprue and filing down the excess metal. Then I used a Dremel to remove some of the defects and a die grinder to polish the casting. I wanted to create a nice contrasting look, so I used liver of sulfur to create a dark patina on the brass. Then I removed the patina from all the high spots with a Scotch-Brite pad and some steel wool. Next, I glued on some red Swarovski crystals to act as eyes, which really brought the statue to life. The final step was to brush on a protective clear coating, and this project was done. This statue was a lot of work, and although it's not a perfect casting, I think it turned out really nice looking. I love the way the eyes look, and believe it or not, this statue weighs almost 5.5 pounds. And as always, I hope you enjoyed watching this video, and if you did, please give it a thumbs up. Tell me what you think in the comments, and subscribe for future projects. Thanks for watching.